Hello Legacy students, Marsh here. So today we're going to look at how to write the equation of an exponential function. You're going to want your notebook, those notes I gave you in class, a writing utensil, and then also a calculator today as well that can do some simple multiplication and division for you. So let's review. Long ago, probably in Algebra 1, you did writing functions of a table. What that was, it allowed us to see if it was a linear function or not linear and any of that nature. So what you normally did to check for that is what we saw if there was a change in the y over a change in the x. So change in the y, it looks like it's a plus 3. We're adding 3 each time, right? So every time I'm adding 3. And then I'm adding 1 each time on this side, right? So this would be a linear function because it's a constant amount that we're going up on both sides. And what we did is normally we wrote it as y equals, this would be 3x, due to the fact of my slope or my rate of change is 3 over 1. And then what we needed was our y-intercept, which we would have to go backwards, right? Because I want to know what if x is 0. So if I would go backwards to 1, I would get 2, right? This would be a 2 because I'm going to basically add 3 between. And then I would have to go backwards 1 more time, so that would be negative 1. So that means my function would be y equals 3x minus 1. Same thing happened here, but notice guys, this is a little different. So we're subtracting 4, we subtracted 1, we added 1, and we added 4. So this was a quadratic, because notice how it kind of mirrors over itself. So this would be a quadratic function that we would be looking at here. And it looks like it'd be the equation x squared plus 2. Because my starting value, my initial start value is 0, 2. So we're looking now at how can I write the equation of an exponential? Well, they're going to continually look like what we were just graphing in last class. But we need to first tell what is each of them being multiplied by. It's basically just continuous multiplication. So I'm going to look and see that each one of those is just multiplied by 3, right? We're just multiplying each and every single one of those numbers by 3. Well, it's going to look something like this formula. F of x equals a times b to the x. Now, let's make a little notes of what these mean. A is your initial value. Or, if you want to think of it, it's your y-intercept. Where are you starting out? How many are you starting with? And then b is your multiplication factor, your growth factor. In this case, what are you multiplying by every single time? Well, in this case, notice guys, we are multiplying by 3 every single time. That's what we're multiplying by. So I know that my b term in this case will be a 3. Then I need to find what's my initial value. What's my y-intercept, which in this case is right here, right? My y-intercept is when my x is 0, so that means my y will be 5. And this would be the equation of that particular function. Y equals 5 times 3 to the x. So let's try this example. So we have some exponential function in the form of f of x equals a times b to the x. And it's given that f of 2 is 96 and f of 3 is 384. So first thing I noticed, these are just ordered pairs. They might not look like it, but they're just in function notation. So this is technically the ordered pair 2, 96 right there, and then 3, 384. So now what I need to do is find out what's the difference, aka what am I multiplying by 96 to get to 384, and then continue that pattern. Well, all that is just times 4. What I did is I took 384 divided by 96, found it's 4. So that means that my multiplication, my factor that I'm multiplying each time is by 4. So if I work backwards, I get that it'll be 124. That's me just dividing. Now divide by 4 one more time. I'm going to get 0, 6. So in this case, my function is going to look, remember, A is what you're starting with, your initial value, aka your y-intercept. So this in this case is 6 times my b value, which is what I'm multiplying by each time, 4. So 6 times 4 to the x should be my answer. So I need to write an exponential for this. So I got 3, 189 on that graph, and also 5, 1701. So I'm just going to put that in a good old table here. Notice I have a blank spot because we got a 4 missing in there. So I kind of need to figure out what's the change in here, but it's not going to be able to be 1701 divided by 189 because there's a big space there. There's actually a division of 9 between these two. So that tells me that each time I'm going to go by 3, right? Because if I went by 9 between two of them, that means I'd have to go by 3 for each of them. So I'm going to go 1701 divided by 3. So I'm going to get 5, 6, 7 here. Divide by 3, because ultimately what am I doing? I'm trying to get to here, right? I want to get to my initial value because that's my A. So what I'm going to do is 189 divided by 3. That'll get me my 63 here. Divide by another 3. We get 21. Divide by another 3. We'll get 7 because I'm just working backwards, right? So if I write my function out, f of x equals, what am I multiplying by? My repeated factor. Or no, my initial amount. My initial amount is 0, 7. So I'm going to have a 7 there. B is my repeated factor, 3 to the x. So let's take a look at my story problem. So we got a zombie virus that's growing at an exponential rate. It's known that after 2 hours, 1,120 zombies existed. And then after 6 hours, 2,086,720 exist. So quite a fast-growing virus. So we're going to determine the equation f of x equals a times b to the x forms the model of the population y as a function of the number of hours x. That means that x is just going to be what we're going to be using. It's going to be in the normal form. So first thing I do is I put it into my table here. So I got 2 hours and 1,120. So what I'm going to also do now is I'm going to fill in the rest of my x values here. Now, I need to figure out what's my repeated multiplication, right? We need to know what's the factor. So first thing I do is I go 286,720 divided by 1120. And I get that that is 256. So now, how am I going to find the repeated value? Well, I know I'm repeating by the same amount, but I am repeating that multiplication between these two 1, 2, 3, 4 times, right? So I'm going to ask myself, something to the power of 4 has to give me 256. Now, gold card, the card that you have, check to see somewhere in your 4th power column there should be the value of 256. 4, right? Value of 4 to the 4th is 256. So that means I am multiplying by 4 each time. How else can you do this? You could also just do some guess and check. 1120 times 2 times 2 times 2 times 2. Does that give me what I need? No. Multiply by 3 a whole bunch of times. Try that. No, 4. There we go. This would be the more mathematical way to do that. So now what I need to do is I need to work backwards, right? I actually don't even need these values, right? I just need this, the initial condition. So what I'm going to do is 1120 divided by 4. That's going to give me 280. So that's at time hour 0. And then I'm going to divide by 4 again. So that means at the start of this epidemic, there were 70 zombies around. So if I start to write the equation, your initial condition, how many zombies did you have to start with? Well, we had 70 zombies, and we are multiplying by 4 each time. So basically you would consider it a 400% increase. So part B, what is the significance of the A value in the context of the problem? So this value right here. So the A, if we're looking at our function here, A, we have said it's always the beginning number of your infected people. So that's the number of people that you're starting out with. The initial amount, if you want to consider it that. That's how I always consider it. Your B is the rate of growth. As we said, that would be like a 400% growth. This is what you're repeatedly multiplying by each time. And with that, that's the end of this video. See you later, Sabers.